The Descartes Rule of Signs tells us the number and location of the real zeros of a polynomial function written in standard form. So the way this works is you start at the beginning of the function f that is written in standard form, and then you count the number of sign changes. So to find the number of positive real zeros, you're going to count the number of variations or changes in the sign of the non-zero coefficients of f, or you're going to have that number less than a positive even integer. So if you start off with a number, you go down in groups, in increments of 2. The number of negative real zeros of f are either the number of variation changes in the signs of a non-zero coefficient of f of negative x, or that number less than a positive even integer. Again, everything going in increments of 2. Now it sounds kind of confusing, and it kind of is, but it's easier to see in practice. So first things first is we're going to use the Descartes Rule of Signs to determine how many positive and negative zeros each function may have. Remember, this just means how many it could have. It doesn't mean that's how many it does have. So we're going to take our function f of x equals 5x to the fourth plus 2x squared minus 6x minus 5. And first we're going to find the number of positive zeros. So number of positive zeros. So we're going to start here at 5, which is positive, go to the next, which is 2, which is positive, go to the next, which is 6, which is negative, then go to the next, which is 5, which is negative. So positive, positive, negative, negative. It changes one time from positive to negative. So since it changes one time, there is one sign change. This means that there can be at most one positive zero. And that's all you do for positives. Now for negatives, we got to do just a little bit more work. So for negative, we have to do f of negative x. So we're going to do first f of negative x, which is going to be 5 negative x to the fourth plus 2 negative x squared minus 6 negative x minus 5, and just simplify it. And so this has become positive, so it just stays 5x to the fourth. This stays positive, so plus 2x squared. This turns to a positive, so positive 6x, and this stays negative, negative 5. And now we do the sign changes again. So positive, 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 negative. There is one sign change again. That means we have at most one negative 0. And I don't have to worry about a number less than a positive even integer, because if I go down by a group of 2 on either one of these, or a unit of 2, I would get to a negative number, which is not possible. So I don't have to worry about it. This is the number of positive zeros there could be, and the number of negative zeros there could be. Now go on to the next one. Negative 4x to the 7th plus x cubed minus x squared plus 2. So for positives, going to count the number of sign changes. So negative, positive, negative, positive. So 1, 2, 3. There are 3 sign changes. So that means this could have 3 or 1, because it goes in groups of 2, 3 or 1 positive zeros. Now we're going to do it again for negative. So I'm just going to abbreviate it. I don't feel like writing it all out. So for negatives, going to be f of negative x, negative 4 negative x to the 7th plus negative x cubed minus negative x squared plus 2. Plus 2. Kind of got away from me there. And so simplify it down. Negative x to an odd power is going to be negative, so this is going to be a positive 4x to the 7th negative x cubed is still going to be negative, so negative x cubed. This will stay the same, so negative positive x squared, and then plus 2. And now the number of sign changes, positive, negative, negative, positive, so 1, 2. So this has 2 sign changes. So this can have either 2 or 0 negative zeros. Now we're going to do it again for this one. Got a whole bunch going on, so again, positive zeros, so it's going to be positive, negative, positive, negative, positive, negative, so 1, 2, 3, 4, 5. 5 sign changes, so it means we could have 5 or 3 or 1 positive zeros. Now again for negative, got to put in our negatives in there, so I'm going to skip all the even ones because those are not going to change, but the odd ones are all going to change, so it's going to end up giving me f of negative x equals negative x to the 5th minus x to the 4th minus x cubed minus x squared minus x minus 1. So all the positives turn into negatives and all the negatives stay negative. And since I start at negative and I go down and they're all negative, I have 0 sign changes, which means I have 0 negative zeros here. And last, f of x equals negative x to the 4th plus x squared minus 1. So again, positive zeros. So it goes from positive to negative, or negative to positive to negative. So it goes 1, 2. There are 2 sign changes. So that means there are 2 or 0 positive zeros. Now I'm going to do it again for the negative zeros. Just replace all the x's with negative, but since they're all even powers, don't really need to do anything. It's all going to stay the same. So f of negative x is going to be negative x to the 4th plus x squared minus 1. Again, 2 sign changes. So since it only changes twice, there could be 2 or 0 negative zeros for this function.